Welcome to the soothing cosmos, where the wonders of the universe unfold in calm and captivating detail. Here, we journey beyond our world, exploring the mysteries of space, the beauty of distant planets, and the secrets written in the stars. If you enjoy traveling through the cosmos with us, remember to subscribe and join our voyage across the universe. The Big Bang, for Dummies. Everything you see, everything you know, everything that exists, from the stars in the night sky to the ground beneath your feet, once fit into something smaller than the tip of a needle. The story of the universe is not just the story of galaxies and planets, but of how time, space, and matter themselves came into being. This story begins with the Big Bang, the most widely accepted scientific explanation for the origin of the universe. And while the name may suggest an explosion, the Big Bang was not an explosion in space. It was the expansion of space itself. In this chapter, we will walk step by step through what scientists believe happened, why they think so, and how you can imagine the birth of everything in the simplest possible way. Imagine inflating a balloon. At first it is tiny, then it grows larger and larger as air fills it. The Big Bang was similar, but instead of a balloon, it was space itself that expanded. The Big Bang model says that about 13.8 billion years ago, the universe was incredibly hot, dense, and tiny. In less than a fraction of a second, it began to expand. That expansion has never stopped, it continues today, with galaxies moving farther and farther apart. The term Big Bang was originally coined as a joke by the astronomer Fred Hoyle, who did not believe in it. But the name stuck, and now it describes the most important idea in cosmology. The early universe unfolded in stages that scientists divide into epochs. Here's a simplified timeline. Planck epoch, 0 to 10 superscript 3 seconds. Physics as we know it breaks down. Space, time, matter, and energy are united. This is the ultimate mystery. Scientists don't yet know what really happened here. Inflation, 10 superscript 3 to 10 superscript 3 superscript 2 seconds. The universe expanded unimaginably fast, faster than the speed of light. A region smaller than an atom stretched to cosmic scales. Quark epoch, the universe was a hot soup of tiny particles called quarks and gluons. Nothing solid, no atoms, just energy and particles colliding. Formation of protons and neutrons. As the universe cooled, quarks combined into protons and neutrons, the building blocks of atomic nuclei. Big Bang nucleosynthesis, 3 to 20 minutes. The first simple elements formed, hydrogen, helium, and traces of lithium. These would later fuel the first stars. After that, the universe entered a long period of cooling and expansion, until the first atoms and, eventually, the first galaxies appeared. For hundreds of thousands of years, the universe was too hot for atoms to exist. Instead, it was filled with a dense fog of charged particles and light. Photons, the particles of light, kept colliding with matter and couldn't travel freely. But around 380,000 years after the Big Bang, the universe cooled enough for electrons to join protons and form neutral atoms. Suddenly, the fog cleared, and light could move freely through space for the first time. That ancient light is still around us today, stretched into microwaves as the universe expanded. We call it the cosmic microwave background, CMB. Discovered in 1965 by accident, it is often described as the afterglow of the Big Bang. It is one of the strongest pieces of evidence that the Big Bang actually happened. Scientists did not simply imagine the Big Bang. Several lines of evidence make it the best explanation we have. 1. The expansion of the universe. In the 1920s, Edwin Hubble discovered that galaxies are moving away from us, and the farther they are, the faster they move. This means space itself is expanding. If you rewind that expansion, everything must have been closer together in the past. 2. Cosmic microwave background. The faint glow of the CMB matches the predictions of a hot, dense early universe. 3. Element abundances. The amounts of hydrogen and helium observed in the universe matched the amounts predicted by Big Bang nucleosynthesis. 4. Large-scale structure. The way galaxies are arranged across billions of light-years fits the idea that tiny fluctuations in the early universe grew into clusters, filaments, and voids as space expanded. Together, these pieces of evidence make the Big Bang the cornerstone of modern cosmology. It's important to clear up some common misconceptions. The Big Bang was not an explosion in space. It was the expansion of space itself. The Big Bang did not happen at one point in space. It happened everywhere at once. The entire universe was compressed into a tiny, hot state, and then it expanded everywhere. The Big Bang does not explain what caused the universe to begin. It only explains what happened after it began. The ultimate why remains a mystery. After the Big Bang, the universe was mostly hydrogen and helium. Gravity slowly pulled this gas together into the first stars, which ignited about 100 to 200 million years later. These stars were huge and short-lived, exploding as supernovae and creating heavier elements like carbon, oxygen, and iron. Without those first stars, there would be no planets, no life, and no us. Over time, galaxies formed, black holes grew, and the universe began to take the shape we recognize today. If the universe began with the Big Bang, how will it end? That depends on the balance between expansion and gravity. If gravity wins, the universe could collapse in a big crunch. If expansion keeps accelerating, the universe may end in a big freeze, where stars die and everything grows dark. Some theories even suggest a big rip, where space expands so fast that galaxies, stars, planets, and even atoms are torn apart. Current evidence, especially the discovery of dark energy, suggests the universe will continue to expand forever, leading to a cold, dark, and empty future. The Big Bang is not just a story about the past. It is a story about us. Every atom in your body was forged in stars that existed because of the Big Bang. The air you breathe, the water you drink, the ground beneath you, all trace their origins to that hot, dense beginning. By studying the Big Bang, we are not just learning about the universe. We are learning about our own cosmic roots. It also raises profound philosophical questions. Why is there something instead of nothing? What came before the Big Bang? These remain mysteries, but they inspire both scientists and dreamers to keep searching. The Big Bang is, at its heart, a story of transformation. From a tiny, unimaginable beginning, the universe blossomed into stars, galaxies, planets, and life. It is not the final word. We may one day discover deeper truths about what sparked it, or whether ours is just one universe among many. But for now, the Big Bang remains the most powerful and elegant explanation of our origins. When you look up at the stars, remember, those stars are not just points of light. They are echoes of a story that began nearly 14 billion years ago, a story in which you are a character.